Hakeem with AutoFix Pals. We have ourselves a 2006 Nissan Quest with the customer complaint of the AC not working with the vehicle at idle. Now we need two things for the AC compressor to come on while the vehicle is at idle. Well, we need two things for the AC to work while the vehicle is at idle. We need airflow across the condenser, and we need Freon in the AC system. Since the customer already told us that the AC works while the vehicle is driving down the road at a decent speed, we can almost eliminate the possibility of this vehicle being low on Freon. Keyword being almost. Now with that said, the absolute easiest thing that we can do is take a look and see if we have airflow across the condenser, meaning are our fans coming on. So based on what we see on the screen, we have the fan on the passenger side working, however it is spinning at a leisurely pace. The fan on the driver's side is not answering the phone and the voicemail has not been set up. So for now, we can skip the step of verifying that we have a proper charge of Freon because I don't know of any vehicle whose cooling fans won't be on the high position when the AC compressor is engaged. It's over 85 degrees ambient temperature and the vehicle is sitting at a standstill. So let's find out why our fans are not working properly. Now what I didn't mention and should have mentioned is that you should check to make sure that the AC compressor is engaged before verifying cooling fan operation. Now in some vehicles, not Nissans, the compressor may be engaged all the time, and that's because the vehicle is likely equipped with a variable displacement compressor. And this type of compressor's displacement will be controlled by an electronic control valve usually located in the rear of the compressor. If you are diagnosing a vehicle with this setup, it's best to have a set of manifold gauges connected to verify the system's charge level and pressures. For our vehicle, we can simply look at the compressor and see if our clutch is engaged. And based on what we see on the screen, we can tell that our compressor is turned on. So, the cooling fans don't work. Well, one of them works, you saw one of them work, and the other one doesn't work. So let's look at the wiring diagram, verify that we have a faulty fan. I'm pretty sure it's the fan motor that's bad, but let's just double check it. And we can do that simply with our test light. But let's look at the wiring diagram and see what we got. Alright? Actually, there's 4 wires going to these fans. Two-speed fan. One's a high-speed, one's a low-speed wire, and then you got 2 grounds. So, do we really need a wiring diagram? I'm going to put one on the screen anyway, so am I in focus? Alright, I'm going to put a wiring diagram on the screen anyway, but we don't really need a wiring diagram. So let's get to testing, and let's go forward with testing these fans, and yeah, let's go. So let's focus in directly on the component that is giving us the issue, which in our case would be the cooling fans. We need to know if these fans are ground side or power side controlled. So fan number 2, which I believe is the fan on the passenger side, has 4 wires, as does fan number 1. And we can see that pins 1 and 2 are supplying power directly from fuse G, which is kind of odd for Nissan to label it a letter instead of a number. So if we check pins 1 and 2, we should see 12 volts all the time. We can easily check that with our test light. Just keep in mind that typically an incandescent test light only pulls about a couple hundred milliamps, and these fans are probably running at several amps. So be sure to load test the circuit before being 100% confident in your diagnosis. So where am I at? I am on, I don't even know what color wire that is. Who cares? Not important. You can see test light is lighting when I put it to ground. That is one of the front wires. Now let's check the other one. And as I suspected, we got power there as well. Okay. See that? Test light is lighting. Power. And as you can see, our test light lights up nice and bright on both pins 1 and 2. So let's check the control side, pins 3 and 4 for a good ground. The control side should only have a ground when the IPDM, the Intelligent Power Distribution Module, is energizing any number of the cooling fan relays. There are 3 relays, and they all have the ability to control the ground for cooling fan number 2. You can pause the video and study the power flow if you wish, but for our test at this moment, we only need to know if we have ground when the AC is turned on. And when we switch our test light to battery positive and check at pins 3 and 4, we do have a test light that is illuminated. Telling us that the fan is being commanded on and both sections of this motor is being energized, so it should be spinning a wee bit faster than what we have right now. So it's official, we have everything we need for fan number 2 to operate properly. Now let's move on to fan number 1. Fan number 1 is power side control, and we can come to this conclusion because there is a constant body ground at pins 3 and 4. So this means pins number 1 and 2 should have a good current sustaining power supply with the AC turned on. Now let's take a look. Alright, so let's get in there. Alright, so we hooked up to one of the black wires. Test light works. That's a ground. Test light works. That's another ground. Now we're hooked up to one of the wires in the front. That is the red and yellow, I believe. Test light works. That's a power supply. Fan should be on right now. Up to the other wire, that is the blue and black with blue, something like that. Either way, test light works, that's a power supply, fan should be on. So pins 1 and 2 do have a good power supply, and again, be sure to properly load test these circuits before being 100% certain on your diagnosis. A significant voltage drop on any of these circuits can come back and bite you in the butt.
Bye.